Welcome, science friends, to data analysis. We're going to use a lot of tables and charts. When we're collecting data in our lab, it's easiest to just kind of have somewhere to put all of those numbers or descriptions if we're using qualitative and quantitative data. And it's also a nice way to organize our observations and data that we're collecting during our lab so that we can use it and then maybe even later turn it into a graph or chart. Looking here, we have a few different examples. We have a bacterial growth chart. That bacterial growth chart is showing us time, so intervals of time of 20 minutes, and every 20 minutes, how many bacteria are we seeing in whatever it is that, like a petri dish or a test tube or something, how many bacteria are we seeing in that time frame. Another one in the upper right corner, we're looking at exercise and heart rate. We're looking at, okay, well, at rest, we have an individual, if this is an individual person in a class, contributing data to whole class data and how those things compare. So at rest, your heart rate's going to be much lower than during exercise or right after exercise as your heart is starting to slow down. But we can see it's organized well. We know what those numbers mean and where they belong. The last data table at the bottom, it's talking about different types of animals, most likely the number of them in a given month. And so again, we're organizing by type of animal and by month and just doing counts, somewhere to put all of that data. So it's not just random numbers in a notebook. We know what those numbers belong to. Another important things to look at in your data set, some of these terms may be familiar from your math class. So, range. The range is the difference between our biggest and smallest values. So in our example here, we have the numbers 3, 7, 5, 5, 2, 8, and 5. So our range is 6, from our lowest number 2 to our highest number 8. So we have a range between the numbers 2 and 8, which would be 6. Next, we're looking at the mean. The mean is just another way to say average. To find the average of a given number set, you sum or add up all of the values or numbers and then divide by the number of those values or numbers. So let's take the same data set from our range. We have a 3, 7, 5, 5, 2, 8, and 5. To find the average number, we would add up all of those, 3 plus 7 plus 5 plus 5 plus 2 plus 8 plus 5, and then we would take whatever that adds up to and divide it by 7, because there are 7 numbers that we added together. Well, all of those numbers together equals 35. 35 divided by 7, because we added together 7 numbers, equals 5. So our mean, or our average of that set, is 5. Median. The median is the middle number of your range. So oftentimes it's really helpful to put your numbers in order from smallest to biggest or biggest to smallest, and you're just going to count out of those numbers. You're not doing any math, just counting across which one is in the middle. So in our data range of 2, 3, 5, 5, 5, 7, 8, the number that's in the middle of those 7 numbers is the number 5. If there's an even number of values in your data set, just average the 2 that are in the middle. So for example, if we had the data range 2, 3, 4, 5, the 2 numbers in the middle, 3 and 4, we'll find the average between them. So 3 plus 4 is 7, divided that by 2, because we're dividing by the number of numbers we're adding together. So our median for that example would be 3.5. The last vocab here is the mode. The mode is the number that shows up the most often in your data set. So again, sometimes it's helpful to put them in numerical order. Sometimes it's easy just to pick it out. It's up to you. But in our data set, 5 shows up the most often. It shows up 3 times. So that would be considered our mode, the most common number. Sample size. Sample size is the number of participants or observations or whatever, the number of data that you are using. So that sample size tells us a lot of information about what we have. It can include the precision of our estimates if we're making estimates. It can show us a lot of analysis power. What can we notice with correlation? Are we seeing a trend of some sort? So sample size is really important. generally speaking, the larger your sample size, the better your data is going to be. Because you don't want to ask a question with 2 people and then say, hey, these 2 people represent the whole school. No, that's not a good size for the size of our school. If you got maybe 75% of our school population, then yeah, that'd be a fantastic sample size. So you want as much as you can get when it comes to data. Last little bit here, we're talking about trends and outliers. Trends, or oftentimes we can use a trend line, is something we can add to a graph to show a direction in which points seem to be going. Usually this is in reference to a scatter plot that we can see here as our example. We can see a trend going sort of in an up direction that is true of all of our dots. So all of those data points are showing, hey, we're going upwards. Outliers are really important pieces of data as well. Outliers is any data point that can offer something that's really different from everything else. So here we have 2 examples of outliers. We can see a sort of cluster and a group of those data points and a trend line for both of these examples. But we have these weird dots, weird points of data that don't seem to be with the rest of the cluster. Those are the outliers. Maybe something weird happened with that data point. Maybe you looked at Fahrenheit instead of Celsius and it threw off your calculations or your data collection. And so those outliers can be really important to know as well. This was data analysis. I hope that helped.